Good morning, students. We have started our chapter electricity and we have completed up to the circuit diagram, and we have shown that how will be the direction of current shown on pen and paper, that is electronic direction and conventional direction. Next, let us see, we will study Ohm's law. Ohm, the name of scientist, he has given the relationship between potential difference and current. So let's see it. What is the relation? Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across its end, provided the physical condition remains constant. Physical condition means here it has been shown the temperature, pressure, etc. So, see here, current is directly proportional to potential difference. Yes, in our daily life we also have observed that whenever the brightness of the light increases or the fan starts running more fast, we say that potential difference increases, means voltage increases. So we feel that by seeing the effect of current, we feel voltage increases. But actually, when a lot of experiment has been done, it is found that when V increases, then only it will affect on I. So we can write this one as V is directly proportional to I. V is directly proportional to I. So whenever you remove the proportionality, we will put one constant in physics. So see here, V is equal to IR. R is the constant known as resistance, and SI unit of R is ohm. It is pronounced as capital Omega. Capital Omega. So, let's say student, then what is resistance? We have studied V, we have studied I, we know about the V potential difference, we know about the current. So, let's see what is the resistance. Resistance is the hindrance offered by a conductor to the flow of current, means opposition to the flow of current. Then who will oppose in the conductor? Who will hindrance in the conductor? Let us see it. Suppose we are having one circuit which is having one bulb, cell and switch, plug key. As soon as switch is on, current started flowing, and direction of current is always used conventional, that is from positive to negative. As the current started flowing, so see here, what is happening? We know that current is nothing but flow of charge in certain fixed path, certain specific direction. This is cell. And we have studied that it is giving potential difference, and potential difference is nothing but the work done to make the electron move in certain fixed path. So here it is doing some work Doing some work means whatever the free electrons. You also know that this is a conductor, and conductor is having free electrons in its outermost shell, that is valence shell, and that free electrons is revolving around the nucleus. So here whatever the free electrons of this conductor, the force applied or the work is done by the cell makes this electron to move in certain fixed path. As it makes to move in certain fixed path, so one electron get free, it will collide with another, like this. You will find that in whole circuit collision is going on. It will collide with one another, like this it is moving. This collision is nothing but resistance. If collision is greater, collision is more, resistance offered is more. Students, suppose I am saying you that you go from Kids Garden to Katrasmore and give this file. Some teacher is standing over here. As you have started, you was not knowing that there was so rush in this road. So as you have started, it was so rush that it's very difficult to even walk. And time is being given to you that within 5 minutes you have to come back. Then what you will do? Naturally you will start moving, you will just collide with another people, then another people, then that collision inside the conductor is resistance. So resistance is the hindrance offered by conductor to the flow of current. If resistance is more, current moving is less. So we have studied just now Ohm's law, that is V is equal to IR. So we can write R is equal to V by I. Means if current increases, resistance decreases. If current decreases, resistance increases. We find only this one. Naturally, if collision will be more, current offered, flowing of current will be less. This resistance we are seeing that is of two types. One is ohmic resistance and another is non-ohmic resistance. If we plot the graph of V and I, what we will find? Students, I think I have taught you that in plotting the graph, we have to take care of x-axis and y-axis. What we have to put in x-axis and what we have to put in y-axis. And I hope you are knowing that in x-axis we are always putting an independent variable and y-axis we are putting dependent variable. So when you will compare V and I, V is independent variable and depending on V, I increases or decreases. So V will be put in x-axis and I will be in y-axis. And when you will draw the data of this, you will find that we will get a straight line. That means V is directly proportional to I. If this type of graph is followed by the conductor, then that conductor is known as ohmic conductor. And ohmic conductor, for example, generally you will find the metals. And when you will see the graph, you will find that silver is very good conductor. That means silver is best conductor. Then what happens when the graph which is not getting a straight line? that type of graph in which we are not getting the slope as a straight line, that type of graph is known as non-ohmic conductor, or it is having non-ohmic resistance. So what we will say, that this non-ohmic conductor, for example, you will get diode. Even some of the non-metals. So these are the two parts. First one follows Ohm's law.